Let's learn about Newton's first law. It states an object in rest will stay in rest, and an object in motion will stay in motion unless acted on by a net force that is not equal to zero. So, let's explain this step by step. What is a net force? What is a net force? So, here's an example. Let's say you have a crate sitting on the ground and it's not moving. That's your crate and it's not moving. We know that two forces are acting on it. There's a force that's going down, which is known as the force of gravity. It acts downward. And then we have our normal force, which acts upward, opposing the force of gravity. What is our normal force? That's the ground pushing back up on the box so it just doesn't keep falling. And our net force is known as the sum of all the forces acting on an object. The sum of these forces, F net, is equal to 0 because the box isn't moving, it's at rest, and these two forces are canceling out. If you add them, you would say normal force minus the gravitational force is equal to 0. F net is 0. That is what our net force means. So now it says an object in rest will stay in rest and an object in motion will stay in motion. Let's first start with an object in rest will stay in rest. What does that mean? So let's go back to the crate example. The object is at rest and we see that the net force is equal to 0. That's why it stays in rest. If the net force were not equal to 0, let's say a man was pushing it to this direction, it would change its motion, and that's because the net force is not equal to 0 anymore. The net force is, so these two cancel out because normal force cancels out with gravity, and let's say this force is F that the man is pushing on the box. We know F net is the sum of all forces. That minus that equals 0, but we have our F now, which is our horizontal component, and that is F net is equal to the force of the man pushing on it. So here we can see that the object is moving because there is a net force that is not equal to 0. And now let's see the case of an object in motion will stay in motion unless acted on by a net force that's not equal to 0. So let's say that we have a soccer ball on some grass. He's on the grassy surface. There's some bumps. You have the grass blades and stuff. And a player kicks the ball right with a force F. Why does the ball come to a stop at some certain point and just not continue moving? That's because the ball has an interaction with the grass, and the grass applies a frictional force in the opposite direction to the motion. So friction, and which is caused by the grass, the contact, and it causes it to stop. The ball would have stayed in motion, but it was acted on by an external net force. Now let's say we had the same ball, but this time it's on an icy hockey rink. Or yeah. The ball with the same force would move for much longer. Like it would travel a much larger distance before coming to a rest, because the frictional force here is smaller. and we know the force is smaller because the arrow is smaller, the vector is smaller. Friction, and then force. Alright, so how do all of these examples relate to Newton's first law? Let's read it again. An object, part by part, let's read it again. An object in rest will stay in rest unless acted on by a net force that's not equal to 0. Here, we have our object, but let's disregard the blue for now. We had our object and it was staying at rest, but then the man decided to push the block, the crate, to the left direction with a net force that was not equal to 0. That's the reason why it started moving. Now let's read the other part of Newton's first law. An object in motion will stay in motion unless acted upon by a net force that's not equal to 0. Let's say the ball was on a frictionless surface. So this surface had friction, and the ball would have kept moving unless but the frictional force caused the ball to come to a stop. And here the ball would have kept moving again, but the frictional force caused it to come to a stop. Let's say we had a surface that has no friction. Then the ball wouldn't come to a stop. There's no other forces that are acting on it. We have our gravity, but that's cancelled out by the normal force. So in the vertical components, the net force is 0. These cancel out. So our only force here in this system with no friction is F. That's why it stays in motion, because there's no net force that's not equal to 0 that can cause it to change motion. Here, the net force here is 0 because there's no acceleration. It doesn't change its motion. There's no force that causes it to change. It's moving at a constant speed. So that's how we know that the net force is 0. That's Newton's first law for you. Thank you.